lesson, we're going to be learning how to determine the factors of a cubic polynomial. So, a third degree function is a function which contains three solutions. So we also call it a polynomial equation. So, it's useful for you to be able to identify the factors in order for you to be able to sketch a graph. But in this lesson, our main focus is not sketching graphs, but is how to solve for x or to determine the factors of a cubic polynomial. So now, in the past, we had equations like y equal to 2x plus 1. Y is equal to x squared minus 4. Where the first one was a straight line, the second one was a parabolic function. Or let's put minus over here. Now, because the exponent of x in the first case is 1, it means when you solve this, you must have one solution of x. Now, because here is 2, when I solve this, I must have two solutions of x. Okay? But now, we're going to talk about another function which is called a cubic polynomial. So y is equal to ax cubed plus bx squared plus cx plus d. So it's important to note that d in this case is the y-intercept of the graph. That's where the graph cuts the y-axis at a point d. So now the question is, how can you factorize such a thing? Or rather, simplify it. Let's say we are given x cubed minus 3x squared. What we can say plus 3x minus 9. So now we're going to learn a new method here called the synthetic division. So there are other methods which you can use to factorize this thing, but the easiest way which I can use here for you to understand it easy is called the synthetic division. Now, how does it work? I'm going to look for a random number which is a factor of 9 or a multiple of 9. Okay? That when I replace it into this whole expression, I get a 0. So now, you must do trial and error for you to get the first term, the first solution, okay? So you don't have to do trial and error for all the terms. No, don't do trial and error for all solutions, please. So I'm going to start by replacing 1 to the power of 3 in the expression to see if this thing will yield 0. If it doesn't give me 0, then it's not the one. Now, here this will be 1 minus 3 plus 3 minus 9. And the answer here will be negative 8. So this thing is not equal to 0. And therefore, we can't take 1. Now, let's try negative 1. So now, if you replace the expression here, negative 1, what do you get? Well, we're going to have, let's see. We're going to have a negative here, a negative, a negative. Now, negative 1 to the power of 3 is negative 1. This will be minus 3, and then minus 3, and minus 9. And this is still not equal to 0. It means negative 1 still won't work in this case. Now, I'm going to pick another number. Now, I'm going to go to 3. Why am I going to 3? I'm not just plugging any random natural number or integer, but I'm plugging the number which is a multiple of d. Okay? Can be both positive or negative, it doesn't matter. Now let's plug in 3 to see if it will yield 0. Now if I replace this with 3 to the power of 3 minus 3 to the power of 3 squared plus 3 times 3 minus 9. Now 3 cubed is 27. 3 times 3 squared is negative 27. 3 times 3 is positive 9 minus 9. Now this gives you 0. So now what does it mean? This means that when I plug in the value of 3, I get a 0 here. So now what does it mean? What is our factor here? Now this means that when I replaced x with a certain number, let's call it b in this case, we can just say plus b, I got a number of 3. Right? When I replaced x, okay, I got 0 over here. Okay, so now when I replaced x into that expression, then it yielded 0. So now from this, what can we conclude? Well, we can say that x minus 3 is a factor. is a fact. So now why do we say x minus 3? Now remember that 3 is a solution. So in order for you to solve for x here on x minus 3, I'm going to say x minus 3 equal to 0, and I'm going to have x as positive 3. Okay, so now this means that 3, in this case, this thing over here is our fact. Okay, x minus 3 was one of the fact before we found the final answer. Okay, so make sure you're able to factorize. So you must note this, what I'm talking about here, that before we reach the final answer, this is the step that comes before it. X minus 3 is one of the factors of this expression. So this is what we're going to use. So now we have found the first solution, we have to find the other solutions. So I'm going to draw an L, that is a bit skewed or twisted. Now the number which I have replaced in the expression, I'm going to put it here. Okay, so I'm going to write 3 over here. Now inside this, I'm going to write the coefficients of the expression. Now a coefficient is a number that comes before a variable, or a coefficient is a number before a variable. Okay, so now here I've got a coefficient of 1, so I'm going to write 1, a coefficient of negative 3 minus 3, followed by positive 3, and then followed by negative 9. Okay, so now a coefficient, I got it from the term which you are trying to factorize here. So it's 1, it's negative 3, it's positive 3, and then it's negative 9. So these are the coefficients. Okay, so now let's see. I'm going to lower down the 1 and I take it down here. Okay, so now how I've solved the other 3 terms, I must make sure that here I always have 0. That's the rule. It must always be 0 here, but we will see as we go that it is indeed 0. Now I'm going to take this one, I multiply it to the 3, and I add the product to the negative 3. So it's like I'm taking this one, I'm multiplying it to this one, and after getting the answer, let's say after getting an answer z, I add it to this one. Okay, so let's do that. Now I'm going to say 1 multiplied by 3, that gives me 3, right? And then 3 plus negative 3, what is that? That must be 0, right? So this means I'm going to put a 0 over here. Now I'm going to say 0 multiplied by 3. Okay, gives me 0, and then I add it to 3 and I get a 3. Now I take the 3, I multiply it to the 3, I get a 9, I add it to negative 9 and I get a 0. So now here it is, you must always have a 0 over here. So just to repeat the process, I take this one, I multiply it to this one, and I add the number, the answer, to this one. Okay, after that I take the 0, I multiply it to the very same 3, and I add the number, the answer, to this one. Okay, I take this one, I multiply by this one, and I add the number to this one, then I get a 0. Now what does it mean? Well, this means that these numbers which you have gotten here will be your terms for the other bracket, because we have solved for the first bracket by using the trial and error method. Okay, so the first bracket is x minus 1, but since this is a cubic function, I must have something squared here. So this is this one, I'm going to have 1x squared, okay, plus 0x, okay, plus 3. Now the exponents must decrease from 2 to 0. Okay, because if I multiply this x by x squared, I'm going to get what? I'm going to get a 3, x to the power of 3, which is the one which we're looking for over there. Okay, so now at the end, the simplification of this will be x minus 1 multiplied by x squared plus 3. So now we can see that this bracket here cannot be simplified any further, and therefore we can leave it here. Okay, we can't factorize this one any further. But just to repeat what I've done here, the first thing, you must find a number that when you replace it into the expression, you get 0. Okay, then after getting 0, you're going to determine each factor that was a step before you got a 3. Okay, and then this was x minus 3. So when you equate this to 0, then you're going to get x is 3. Then this is the 3 which you plugged over there. Okay, so just to illustrate this more nicely so that everyone understands this. Now if I replace 2 and I get a 0 in the expression, then my factor is x minus 2. If I replace negative 3 and I get the expression as 0, my factor is x plus 3. Okay, so the difference is in the sign here. If here is positive 2, it's negative 2, negative 3, positive 3. So this is called the factor theorem. Okay, so when I replace that certain number in the expression, I must get 0. So this is how your final answer will be, because you can see that you cannot factorize this any more further. Okay, so let's try a second example. Now let's say you are now given x cubed plus x squared minus 4x minus 4. Okay, so now remember, I must try all the possible values of negative 4, which will make this expression be equal to 0. That is to find the first solution. Okay, now let's start with positive 1 and see if it will work. Now if I replace 1 with the expression, will be 1 to the power of 3 plus 1 squared minus 4 times 1 minus 4. Now does it work? Well, let's see. Well, 1 cubed is 1 plus 1 minus 4 minus 4, and well, this gives us it must be negative 6. Okay, so it is not equal to 0, and therefore we can't check this one. But now let's try negative 1. So I'm going to say negative 1 to the power of 3 plus negative 1 squared minus 4 times negative 1 minus 4. Now any number, if you cube a negative, it remains a negative, so this is negative 1. When you square a negative, it becomes a positive, so this is positive 1. Now negative 4 times negative 1 is positive 4 and minus 4. Now look at this, negative 1 plus 1 is 0, 4 minus 4 is 0, 0 plus 0 is 0. So now because when I plug negative 1 in the expression yields 0. Now what does it mean? This means that therefore x plus 1 is a factor. I hope it makes sense to everyone. So x plus 1 is a factor of this expression. So this is the first solution of the expression. Okay, so now we're going to solve for the other ones using the very same method which we have used in the previous example. So you can feel free to pause the video and check the answer after to see if you've got it correct. Now I'm going to draw, as usual, our L here. Now I've replaced negative 1, so I'm going to put a negative 1 over here. Now here I'm going to write the coefficients of this expression, which is 1, 1, negative 4, and negative 4. So I'm going to write 1 here, 1 here, negative 4 here, and negative 4 here. Now for the first term, I take it down. So whatever I see here, I just take it down. Now I take the positive 1 over here. This positive 1, I multiply it to negative 1, and I add the answer, I add it to this one. Okay, so now let's see. 1 multiplied by negative 1 is negative 1. Okay, negative 1 plus 1 is 0. Now 0 multiplied by negative 1 is 0. In number times 0 is 0. Now 0 plus negative 4 is negative 4. Now negative 4 multiplied by negative 1 is positive 4. And I add the positive 4 to the negative 4 and I get a 0. Now remember that rule of ours, that the last one here must always be, it's a must, always it must be 0. Okay, that's what will give you a hint that okay, you've done the correct thing. Now we've got the first expression, which is the one which I wrote here on x plus 1 is a factor. So we've got the first bracket over here, and I'm just going to quickly write that as x plus 1. Now because here I have an x, I must multiply something which is something x squared. Okay, and what is that something? The coefficients are the ones which I have here. So this will be the coefficients. Okay, so this will be the coefficient of x squared of x, and this will be the constant. Now let's see, this will be 1x squared, which is simply x squared, plus 0x, which is 0, minus 4. Okay, but notice something here, this thing can be broken down further. Okay, so we can still factorize this one. It's a difference between two squares, so I'm going to factorize it further. So here I'm going to have x plus 1. Now I'm going to break down the x squared minus 4. So likewise, I'm going to put an x here, an x here. How do I get a negative? By multiplying a positive and a negative, and the factors of 2, this must be 2 and 2. That will cancel the middle terms. And at the end, this is your expansion. So in short, this is how we can use the factor theorem as well as the remainder theorem to calculate or to factorize a cubic polynomial. So bear in mind that what we've said before, if I have got a 3 here, I must have 3 solutions. But if you check on the previous example, when the other bracket it cannot be simplified, well, you can say no solution to it. But if it can be factorized any down, then you can go ahead and factorize it. So I hope this was a clear introduction to factorizing cubic polynomials. So bear this in mind that even when we are sketching graphs, we're going to be using the same principle. Thank you for watching.